Hey mathematicians, in this lesson we'll be dividing whole numbers and fractions with a remainder by using a model. All right, let's go and get started here. Our first example says, if I cut 2 chocolate bars into 3/4 sized pieces, how many pieces will I have? Well, I've already started and I've created a model here that shows 2 chocolate bars, and what I've done is I've divided the chocolate bar up into groups or sizes of 1/4. Now the reason I've done this is because I'm going to be making 3/4 sized groups out of these 2 chocolate bars. That's what division is making groups, a certain sized group, out of another amount. So in this case, we're going to make 3/4 sized groups. So every time I have a group of 3/4, that represents one whole group of 3/4, which is right there. You can see those are 3/4. That's a group of 3/4. Here would be a second group of 3/4. Now comes the part of the lesson that I want you to really focus on. This is where we have a remainder. We don't actually have another group of 3/4. We actually only have we only have 2/4 out of the 3/4 that we need. So how do we represent this as a remainder? Well, we're going to pretend. We're going to pretend for a moment that there was another chocolate bar out here. Now there's not. We can see that there's not another chocolate bar. But we're going to pretend that we had another chocolate bar out here, and it is ready to be divided up into groups of 3/4 as well. If we had this chocolate bar, this would be another group of 3/4. You can see that there are 3 of them in there. But we don't actually have all 3 pieces. We only have 2 out of the 3 pieces. So we would represent what's left over here on the remainder of the actual 2 chocolate bars as 2 out of 3 pieces that we need. So if I have 2 chocolate bars and I divide them up into groups, equal sized groups of 3/4, I would end up with 2 whole groups of 3/4, and then I would end up with 2 out of the 3 pieces that I would need to make another group of 3/4. All right, let's try a second example here. So, Dave is making pizza. He has 4 blocks of cheese. If each pizza needs 3/5 of a block of cheese, how many pizzas can Dave make? So let's find out how many pizzas Dave can make here with his cheese. Now I'm going to use my 4 models here. Each one represents an awesome block of Tillamook sharp cheddar cheese, one of those 2-pound blocks, the kind that I can make myself sick on by eating all 4 of them in one sitting. All right, let's see here. I've already divided up each of my models into fifths, and I'm going to just start labeling here that these are fifths. And I'm actually not going to label all of my models here just because time. All right, what I'm going to be doing now is, again, Dave has these 4 blocks of cheese, and he's going to break them up into groups of 3/5. So every time I have 3/5, that's a group of. So there's one group, that's a group of 3/5. So here is another group of 3/5. You can see 1, 2, 3. So here's 1, 2, 3. There's 3 pieces, 3/5. That'd be my third one. And I can keep going. You can see that each time I'm making a group, there are 3/5 of a block in there. Here's 5. Here's 3/5. There's 6. And now we're left with these 2 pieces at the end. We've got this leftover amount. We have 1, 2. We have 2 pieces out of the 3 that we would need to make 3/5. So at the end here, I've got 2 pieces out of the 3 that I would need to make another group of 3/5. So what I've found out is if Dave has these 4 blocks of cheese and he divides them up into groups of 3/5 to make pizzas, he can make 6 2/3 of a pizza with his cheese. All right, let's do one last example here. Aaron is running a 3-mile race with water breaks every 2/3 of a mile. How many water breaks will there be during the race? Now in this model, I'm going to actually use a number line. I'm going to use a number line because we're talking about distance, and a number line or a ruler would measure distance. And what I know is that Aaron is running 3 miles. So I've drawn here on my model, I've drawn out to 3. Each of these whole numbers represents a mile. And I need to find out how many 2/3 groups are there, so that every 2/3 Aaron gets to stop and have a water break. And so what I'm going to do is I'm going to label my number line with thirds. And the reason that I'm labeling it with thirds is so that it's easier for me to make groups of 2/3. So let's see what we end up with here. I can see that this is a group of 2/3. I've got 1/3 and 2/3, so that makes a whole group of 2/3. Here is another group of 2/3. Here is a third group of 2/3. Again, I'm making groups of 2/3. And then here is another group. There's 4 groups. You can see I've got 4 whole groups of 2/3 so far in my 3-mile number line. And what I'm left with, though, is this last little third. There's just one of them. There's 1/3 out of the 2 that I would need. If my number line continued and it kept going, you could see that, hey, there might be another third out there to make my group of 2/3. But in this case, I don't actually have it. I've got one of my pieces out of the 2 that I would need. So I've got 1/3 out of the 2 pieces, the 2/3 that I would need in order to solve this problem. So what I've found here by using my model is that if Erin runs a 3-mile race and she breaks it up into these 2/3 mile water breaks, if she has them every 2/3, she would end up getting 4.5 water breaks along the way. All right, mathematicians, in this lesson we divided whole numbers and fractions with a remainder by using a model.